Hey, Michael, the rotor on this keeps sticking.
It's probably just a little gummed up. I gotta run, line 4 is down, and they're waiting for me. Just put a little degreaser on the shaft there.
Okay, where is it?
It's in the white bottle on the shelf.
Okay. Oh man, they're all white bottles. This must be it.
This didn't have to happen. Most accidents really don't have to happen. There's regulations, procedures, and processes that, if followed, would have prevented Anne from getting burned by that chemical. The key to working safely with chemicals is information. Information about their hazards and how to protect ourselves from those hazards. So, let's learn about the important information, and then we'll come back and fix what's wrong with this picture. Now, of course, it is possible to work with chemicals safely. Millions of us do it every day. To help provide all of us with the information we need to work safely, the Occupational Safety and Health Administration, OSHA, has established the Federal Hazard Communication Standard. You've probably heard it called Hazcomm, or Right to Know. It's often called Right to Know because that's what it's designed to do, to help us know about any chemical hazards we may be exposed to, and to help us know how to work with and around chemicals safely. The Hazard Communication Standard now mandates the use of the Globally Harmonized System of Classification of Labeling of Chemicals, GHS for short. It's all information that gives employers a set of guidelines for identifying chemical hazards and training employees about chemical safety. Your employer has a written hazard communication program in place that includes a list of all the hazardous chemicals in the workplace and safety data sheets for each hazardous chemical that are readily available to employees. We'll look at these important documents later in this video. The written program also ensures that all containers have labels that identify their contents and have appropriate warnings about their hazards. We'll look at the information that must be included on the labels. There must also be a plan to inform and train employees about chemical safety procedures. To begin with, there are two types of hazards to be aware of: physical hazards and health hazards. Physical hazards can result in effects like burns, fires, or explosions. Chemicals that present physical hazards include substances like combustibles, including fine dust particles, flammables, corrosives, and explosives. Some compressed gases or chemicals that react strongly with water or other chemicals also present physical hazards. Health hazards can result in effects ranging from mild skin disorders to cancer or birth defects. Some chemicals can damage certain organs such as our lungs, kidneys, or liver. Some can damage body systems such as our nervous system or reproductive system. The consequences of these hazards to our health can be acute or chronic. Acute means the chemical affects us rapidly, and the effect results from a single exposure. Chronic effects take place over a longer period of time. Often the effects don't show up until sometime after the exposure, or after repeated exposures. The point is, the effect from a chemical may not be as apparent or as immediate as say, falling off a ladder, but it can be just as deadly. This is Larry. We're going to be running into Larry a lot in this program as we learn about working with chemicals safely. And we're going to run into some situations that will need some, well, fixing. In order to work safely with chemicals, it's important to understand how they can get into our bodies. We often see this called routes of entry. Let's take a look at some examples out in the workplace. One way chemicals get into our body is through inhalation, the simple act of breathing. Larry's not wearing his respirator properly. He's breathing a lot of vapors and contaminating the inside of his respirator. Let's fix that. Another route of entry is ingestion or swallowing. Now, Larry wouldn't intentionally eat or drink a hazardous chemical. Let's take a break.
Oh yeah, good.
But that's what he's doing by handling food and not washing his hands. Let's go back to Larry's work area. It's best to keep food or beverages away from work areas where chemicals may be present. Another way chemicals enter our body is right through the skin, absorption. Let's fix this picture. Wearing protective equipment such as gloves and safety glasses can help prevent absorption. Now let's see where we can find information that can help us work safely with chemicals. Let's start with the source of information you've probably run into most often. Labels. Labels can tell us a lot more about a chemical than just its name. The product identifier is how a chemical is identified. It could be the chemical name, a code number, or a batch number. But it must be the same identifier on the label and the safety data sheet. We'll look at those shortly. Next, the supplier identification shows the name, address, and telephone number of the manufacturer, importer, or other responsible party. Here we have the signal words. These are used to alert you of the relative level of severity of the hazards. There are only two words you'll see used as signal words: warning and danger. Warning is for less severe hazards. I'm warning you. And danger is for more severe hazards. Danger! That makes sense. Even if a chemical has more than one hazard, you'll only see one word. If there is a dangerous hazard, you'll see the word danger. Also, in this area, you'll see the hazard statements listed. This describes the nature of the hazard and, where appropriate, the degree of hazard. For example, this label states combustible liquid and may be fatal if swallowed or enters airways. You should always see the same hazard statements for a chemical, no matter who produced the chemical. You'll also find the precautionary statements, which tell you how to protect yourself and others from the hazards. These statements will tell you how to prevent or minimize exposure to the hazards, how to safely handle and store the chemical, how to respond to accidental exposure, such as first aid needed, and how to extinguish a fire involving the chemical. You'll see why it's important to be familiar with these precautions. The creator of the label may also include supplemental information they feel is helpful, such as specific directions for use, disposal, or PPE. Labels also include a visual tool for communicating the hazards of a chemical: pictograms. There are 9 different pictograms being used to identify hazards. Let's look at them one at a time. Health hazards. This is the symbol that will alert you to health hazards associated with a chemical. This could mean the chemical can cause cancer or be toxic to certain organs, your reproductive system, or your respiratory system. An exclamation mark indicates there are health hazards, but not as severe as those included in the health hazard pictogram. For example, the chemical may cause irritation to your skin, eyes, or lungs. Flame. This one should be pretty clear. If you see this symbol, the chemical has fire potential. A gas cylinder pictogram indicates the container has gas under pressure. This symbol is for corrosion. You can see it shows something being poured onto metal and on skin with a damaging effect. An exploding bomb. Well, this chemical may be explosive. It may also be self-reactive or an organic peroxide. A flame over a circle indicates the chemical is an oxidizer. Oxidizers can cause combustible material to burn spontaneously without an ignition source, such as a spark or flame. They can also make a fire more intense. A skull and crossbones indicates acute toxicity. This means the toxic effects could happen within days, hours, or even seconds after an exposure to a chemical. There is also a non-mandatory pictogram that you may encounter. This indicates that the chemical has environmental hazards. Hi, Anne. Remember Anne from the beginning of this video?
This must be it.
She's just guessing. If a hazardous chemical is transferred to another container, unless you are the only person that will use it, that container must also be labeled. Remember this? Let's fix this.
This must be it.
What are you looking for?
The degreaser.
Yeah, that's not this. This is actually acid. I forgot to put the label on it. So yeah,
That's not what I want.
No, the degreaser is right here. So
Ah, I see. Perfect.
yeah,
Thank you.
there you go.
Your workplace may also design its own labeling system. If they do, those labels could include all the information and symbols we just explained, or they could include some of those words and symbols as long as there is specific information that is immediately available on the chemical. Even more information about a chemical can be found on one of these: a safety data sheet, SDS for short. Manufacturers and distributors who supply chemicals to your workplace are required to provide an SDS for each hazardous chemical they supply. This information on the SDS must be available to you, the employee. There are 16 standardized sections on the SDS that will help you find the information, no matter who the supplier is. The first section identifies the chemical the same way it appears on the container label. The name, address, and phone number of the manufacturer or distributor should be listed here. This section will also include the recommended use of the chemical, a brief description of what it actually does, and a list of any restrictions on its use. Section 2 identifies the hazards of the chemical and the appropriate warning information associated with those hazards. Much of this information is the same as it is on the label. This will include the hazard classification of the chemical, pictograms, the signal word, hazard statements, and precautionary statements. Section 3, composition information, identifies the ingredients contained in the product, including impurities and stabilizing additives. The information will include the chemical name and other names it may be known as. It will also list the Chemical Abstract Service, CAS number, and other unique identifiers. If the product is a mixture, there will be the same information for each ingredient in the mixture, as well as exact percentage for each ingredient. This section is important if you are exposed to a chemical. It will tell you what first aid to use for any route of entry, whether it's by skin or eye contact, inhaling, or ingesting. It will also describe the most important symptoms or effects from the chemical. It will give you recommendations for immediate first aid, medical care, or special treatment when necessary. Knowing these procedures, as well as the location of the first aid and eye wash stations before an emergency occurs, will help you to respond quickly. This section provides recommendations for fighting a fire caused by the chemical, including the proper fire extinguisher or equipment to use. It may recommend special protective equipment or precautions for firefighters. It will also advise you on any hazards that could develop if the chemical burns. Section 6, accidental release measures. What to do if a chemical is spilled or leaked from a container.
Yeah, very funny. You still owe me $5.
This will tell you how to contain and clean up a spill to minimize exposure to people or the environment. It will describe precautions such as eliminating ignition sources or providing sufficient ventilation. There may be information about emergency procedures such as the need to evacuate an area or protective clothing to use. It may have information on containing the spill such as covering drains or the type of absorbent material to use for cleanup. This section provides guidance on the safe handling practices and conditions for safe storage of the chemical. It will tell you about any incompatible chemicals, ones that should be kept away from each other. It will also describe the conditions needed for safe storage, such as adequate ventilation. Some of the most important information for the person working directly with the chemical is found here. This section indicates the exposure limits, engineering controls, and personal protective measures that can be used to minimize worker exposure. The amount a person can safely tolerate is listed here. It's listed as the threshold limit value, TLV, or the permissible exposure limit, PEL. It's usually listed as parts per million or milligrams per cubic meter. For example, Here's a parts per million recipe for a root beer float. 1 small scoop of ice cream to a tanker truck of root beer. We're obviously talking about very small amounts that could be very harmful. This section will give us information on the type of personal protective equipment that must be worn, such as boots, aprons, gloves, or goggles. If respiratory protection is needed, there will be a description of the type of respirator that must be used. This section will also tell us whether the general room ventilation is sufficient, or whether local exhaust ventilation is required. Section 9, Physical and Chemical Properties. There are a lot of technical terms that could be listed here, and not every chemical will have information on each of these terms. But it's important to understand how some of them relate to our safety on the job. Vapor density, for example, tells us if a gas or vapor is heavier or lighter than air. A gas or vapor with a vapor density less than 1 is lighter than air and would rise to the ceiling if there was a leak. A gas or vapor with a vapor density greater than 1 is heavier than air and would sink to the floor. What does this mean to you? Well, when the gas or vapor stays near the floor, there's a risk of breathing the vapor. Or if it's flammable, it could be ignited by a spark from machinery. Specific gravity tells us that something is heavier or lighter than water. If a chemical's specific gravity is more than 1, it will sink in water. If it's less than 1, it floats on water. What does that have to do with our safety? Well, remember, a chemical with a specific gravity of less than 1 floats on water. Now, in the event of a fire, if this chemical were burning and you sprayed water on it, you may actually spread the fire rather than extinguish it. The chemical's normal appearance and odor are described so that we can detect any leaks or spills and recognize any changes in the chemical's form that may increase its hazards. Another important term here is flash point. This is the lowest temperature at which a flammable or combustible liquid will give off enough vapors to easily ignite. Diesel fuel has a flash point of 125 degrees Fahrenheit and does not easily ignite unless a temperature is higher than 125 degrees. Gasoline, on the other hand, has a flash point of minus 45 degrees Fahrenheit. That means at temperatures warmer than minus 45 degrees Fahrenheit, gasoline starts to give off enough vapors to easily ignite. Section 10, Stability and Reactivity. Some chemicals react violently with other chemicals, or even water or air. This section alerts us to any substance or situation that a chemical should be kept away from. For example, watch how these chemicals react when they come in contact with each other. Section 11, Toxicological Information. The most likely routes of exposure, such as inhalation, ingestion, skin or eye contact, will be listed here. It will also include a description of the symptoms of exposure. Section 12, Ecological Information. How the chemical infects the environment, the air, water, plants, and animals. Section 13, Disposal Considerations. How to properly dispose of or recycle the chemical, or its container. Section 14, Transport Information. It contains any special precautions needed for transporting the chemical inside or outside your facility. Section 15, Regulatory Information. Any safety, health, or environmental regulation that applies to the chemical that is not found anywhere else in the SDS. And finally, Section 16, Other Information. This will tell you when the SDS was prepared or last revised. and other information not found elsewhere on the SDS. It's everyone's responsibility to know where the SDS are located and how to read them. Use the SDS as a guide. There may be additional handling and safety procedures at your workplace. When there is a question on procedure or equipment, check with your supervisor. The Hazard Communication Standard and your company's compliance program can give you the information you need to work with chemicals safely. But it's everyone's responsibility to use that information. We all have a role and responsibility to keep ourselves and our coworkers safe.